The National Electrical Code, specifically Section 310.15b2, addresses the issue of ampacity derating for non-metallic, or NM, cables. This is especially important when multiple NM cables are bundled together. The core concern stems from the heat generated by current-carrying conductors within these cables. When cables are bundled, the heat dissipation is reduced, potentially leading to an increase in conductor temperature. If this temperature exceeds the insulation rating of the conductors, it can degrade the insulation, creating a fire hazard or causing premature failure of the electrical system. The code specifies that when more than 2 NM cables, each containing 2 or more current-carrying conductors, are bundled together and passed through wood framing that is to be fire or draft stopped using thermal insulation or sealing foam, the allowable ampacity of each conductor must be adjusted according to Table 310.15b2. This table provides derating factors based on the number of current-carrying conductors in a bundle. The commentary highlights the importance of complying with these derating requirements. Failure to do so can lead to overheating of conductors and potentially dangerous situations. The code addresses situations where single conductors or multi-conductor cables are stacked or bundled longer than 600 mm or 24 inches without maintaining spacing and are not installed in raceways. In such cases, the allowable ampacity must be reduced as shown in Table 310.15b2. This requirement aims to prevent overheating of type NM conductors where they pass through draft and fire-stopped material. Electricians might need to adapt their practices to meet these requirements. Instead of densely packing cables together, they may need to drill more holes in framing members to maintain spacing between the cables. This spacing allows for better heat dissipation and reduces the need for significant ampacity derating. There are several key aspects to consider when working with NM cables and ampacity derating. Firstly, identify current-carrying conductors. The derating factors in Table 310.15b2 are based on the number of current-carrying conductors in a bundle. Grounding conductors and neutral conductors that only carry the unbalanced current from other conductors are not typically counted as current-carrying conductors. Secondly, determine the bundling length. The derating requirements apply when cables are bundled for lengths exceeding 600 mm or 24 inches. If the bundling length is shorter than this, derating may not be necessary. Thirdly, understand the derating factors. Table 310.15b2 provides derating factors that must be applied to the allowable ampacity of the conductors. For example, if there are 4 to 6 current-carrying conductors in a bundle, the allowable ampacity must be reduced to 80% of its original value. Fourthly, consider ambient temperature. The ampacity of conductors is also affected by the ambient temperature in which they are installed. If the ambient temperature is higher than 30 degrees Celsius or 86 degrees Fahrenheit, additional derating may be required. Table 310.15b provides correction factors for different ambient temperatures. Fifthly, calculate the corrected ampacity. To determine the corrected ampacity of a conductor, multiply its allowable ampacity by the derating factor from Table 310.15b2 and the correction factor from Table 310.15b, if applicable. Sixthly, select the appropriate conductor size. Ensure that the selected conductor size has an ampacity equal to or greater than the calculated corrected ampacity. This will ensure that the conductor can safely carry the intended load without overheating. Maintaining spacing between NM cables is a crucial factor in minimizing the need for ampacity derating. When cables are spaced apart, they can dissipate heat more effectively, reducing the temperature rise in the conductors. There are several methods for maintaining spacing between cables. Firstly, drill separate holes for each cable. This is the most effective way to ensure adequate spacing. When drilling holes, make sure they are large enough to accommodate the cables without compressing them. Secondly, use cable straps or ties to secure cables to framing members. When using straps or ties, avoid over-tightening them, as this can compress the cables and reduce their ability to dissipate heat. Thirdly, install cables in a single layer. Avoid stacking cables on top of each other, as this can trap heat and increase the temperature of the conductors. The type of insulation used in NM cables also plays a role in their ampacity rating. NM cables typically use thermoplastic insulation, which has a maximum operating temperature of 90 degrees Celsius or 194 degrees Fahrenheit. However, the allowable ampacity of NM cables is usually based on a lower temperature rating, such as 60 degrees Celsius or 140 degrees Fahrenheit, to provide a margin of safety. When selecting NM cables, ensure that they are rated for the intended application and that their ampacity is sufficient for the load they will be carrying. The NEC provides detailed tables and guidelines for determining the allowable ampacity of conductors. These tables take into account factors such as conductor size, insulation type, ambient temperature, and the number of current carrying conductors in a raceway or cable. It is important to consult these tables and follow the NEC guidelines to ensure the safety and reliability of electrical installations. In addition to ampacity derating, there are other considerations for installing NM cables. Firstly, protect cables from physical damage. NM cables should be protected from physical damage by installing them in locations where they are not likely to be struck or abraded. If cables must be installed in exposed locations, they should be protected by conduit or other approved means. Secondly, support cables properly. NM cables should be supported at intervals not exceeding 1.4 meters or 4.5 feet and within 300 millimeters or 12 inches of boxes, cabinets, and fittings. This will prevent the cables from sagging or becoming damaged. Thirdly, avoid bending cables sharply. NM cables should not be bent sharply, as this can damage the insulation and reduce their ampacity. The minimum bending radius for NM cables is typically 5 times the diameter of the cable. Fourthly, use approved fittings. When connecting NM cables to boxes, cabinets, and fittings, use only approved fittings that are designed for use with NM cables. This will ensure a secure and reliable connection. Fifthly, follow manufacturer's instructions. Always follow the manufacturer's instructions when installing NM cables and fittings. This will help to ensure that the installation is done correctly and safely. By understanding the requirements for ampacity derating and following best practices for cable installation, electricians can help to prevent overheating of conductors and ensure the safety and reliability of electrical systems. Remember to always consult the latest edition of the National Electrical Code and local regulations for specific requirements and guidelines. The NEC is a comprehensive set of standards that are designed to protect people and property from electrical hazards. By adhering to these standards, electricians can help to create safe and reliable electrical installations. Remember the importance of proper planning and execution when working with electrical systems. Taking the time to understand the code requirements and following best practices can help to prevent costly mistakes and ensure the safety of yourself and others. Electrical work can be dangerous if not done properly. If you are not a qualified electrician, it is best to leave electrical work to the professionals. A qualified electrician has the training and experience necessary to perform electrical work safely and correctly. They can also help you to ensure that your electrical system meets all applicable codes and regulations. There are several resources available for learning more about electrical safety and the National Electrical Code. Firstly, the National Fire Protection Association, or NFPA, publishes the National Electrical Code. The NFPA website also offers a variety of resources on electrical safety. Secondly, the International Association of Electrical Inspectors, or IE, is a professional organization for electrical inspectors. The IE website provides information on electrical codes, standards, and safety. Thirdly, many electrical supply companies offer training courses on electrical safety and the National Electrical Code. These courses can be a valuable resource for electricians and other electrical professionals. Fourthly, many community colleges and technical schools offer courses in electrical technology. These courses can provide a comprehensive understanding of electrical systems and the National Electrical Code. Staying up to date on the latest electrical codes and safety practices is essential for all electrical professionals. The electrical industry is constantly evolving, and new technologies and regulations are being developed all the time. By continuing to learn and improve their skills, electricians can ensure that they are providing the safest and most reliable electrical services possible. This section of the code is designed to prevent the overheating of conductors in specific situations where heat dissipation is limited. When NM cables are bundled together and passed through insulated or sealed framing, the heat generated by the conductors can build up, potentially exceeding the temperature rating of the insulation. The derating factors in Table 310.15b2 are intended to compensate for this increased heat by reducing the allowable ampacity of the conductors. This ensures that the conductors do not overheat and that the electrical system operates safely. It's essential to remember that these derating requirements apply specifically to NM cables. Other types of cables, such as armored cable or metal-clad cable, may have different derating requirements. Always consult the NEC and the manufacturer's specifications for the specific type of cable being used. When working with electrical systems, safety should always be the top priority. By understanding the requirements for ampacity derating and following best practices for cable installation, electricians can help to prevent electrical hazards and ensure the safety of people and property. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. The purpose of Section 310.15b2 is to address a specific scenario where the heat generated by bundled NM cables can become trapped, leading to a potential overheating hazard. The requirement to derate the ampacity of the conductors in these situations is a critical safety measure that helps to prevent fires and other electrical problems.